Lesson 5.3, Transformations and Symmetry of Polynomial Functions. In this video, we will describe transformations performed on one function given its equation in terms of another function. Some key terms. Polynomial function. So a polynomial function is a sub n x to the nth, this is the general form, plus a sub n minus 1 x to the n minus 1 plus all the way down to a sub 2 x squared a sub 1 x and then a naught. A naught just meaning constant term. All the a's are just coefficients, and then x can be up to as high power as we want. Common ones that we see besides the quadratic and the cubic and linear are quartic, which is a function whose degree is 4, and quintic, which is a function whose degree is 5. The equation for the polynomial p of x is given. The equation for the transformed function m of x in terms of p of x is also given. Describe the transformations performed on p of x that produce m of x. Then write a specific equation for m of x. Alright, so this piggybacks off of what we did with quadratic functions. So the negative here means that we have a horizontal reflection. Okay, the plus 2 here at the end is a vertical translation. Point 5 is the part that we struggle with the most, and that is a horizontal compression. No, yeah. By a factor of 2. And then the last thing it asks us to do is write this in terms of a specific equation. So they're asking you to replace the p with what p is actually. So since p is x to the fourth, what we have is negative parentheses 0.5 x in parentheses, and then fourth on the outside plus 2. And that's what our function is, our specific function. So what I'd like you to do is try p of x on your own, or try number 5 on your own, and describe the pieces, and then check and see how well you know your stuff. Go ahead and do that now. Okay, so hopefully you saw that 4 is a vertical stretch by a factor of 4. You saw that the minus 3 is a horizontal translation, right 3 units, and the minus 5 is a vertical translation, down 5 units, and then the general or the specific equation would be m of x equals 4 parentheses x minus 3 cubed minus 5. And with that, that's how you write equations. That's how you describe transformations performed on p of x that produce m of x, and then write specific equations for m of x.